Multiplying binomials resulting in a difference of squares. A difference of squares is two terms that are perfect squares with a subtraction sign in the middle. So we could have x squared minus 36, for example. When we go to factor x squared minus 36, this is going to end up being x plus 6 and x minus 6. If we were to multiply this back out, multiplying the first terms, we get x squared, and multiplying the last terms, we get minus 36. But what happens when we multiply the inner terms and the outer terms is we end up with a plus 6x and a minus 6x that cancel each other out. And we just end up with those two terms that are perfect squares with a subtraction sign in the middle. So that's the difference of squares. The problems that we have here are already in that format where we've got the exact same binomial. One has a positive sign and one has a negative sign. If I were to multiply this out systematically, the first terms would be 2x times 2x. The outer terms are negative 14x, and then the inner is positive 14x. And then the last terms are a negative 49. So I've got 4x squared minus 49. This results as a difference of squares. The first term is a perfect square, the last term is a perfect square, and those middle terms ended up canceling each other out. If I already know that this pattern exists, when I see something like this, like I do in example B, I can just focus on the first terms being multiplied together and then the last terms being multiplied together. Because I know that the two middle terms are going to cancel each other out.